Hi, this is Andre again. As you're probably waiting for the MicroPET release 2, I have some other updates for you. So today I'm going to talk about a new ROM feature, new CPLD video features, some very nice video mode emulation that I'm going to show you, talking about the keyboard option, and looking at how the release 2 will be looking like. So, showing you off the new ROM features. So if you boot the machine, you can boot into ROM, and then you can see we have the custom Editor Rom, and this is one from Steve Gray's Editor Rom project. So you can actually use any kind of combination you would like. What I have decided is to add the wedge onto the machine so that it's kind of easier to work with it. Going on to the CPLD features. Yeah, and I think the wedge maybe needs some more working on there as well. Going on to the CPLD feature, let's look at the benchmark. What you can see here is that I have managed to do a split clock implementation for the full speed mode, so that the I/O with the timer get the full almost 10 megahertz system clock, whereas the CPU gets a slower clock. I think I've mentioned in the previous video that the CPU is not really working well with the ready input and the CPLD, so that's why I have chosen to stretch the clock cycles for the CPU when it has to wait for the video access, and that's what we can see here. So you have the different modes as well. Then there is another option that I would like to show. As you know, there is the Interlaced Mode that you can switch on by using emulated CRTC registers. So you can set the interlace bit, and then what you get is the not every second line is drawn on the VGA output, but every line. And then you can actually do something something on the video control register, which is not a CRTC register, and you could actually do this. You can then compress the characters vertically and basically have again 8 pixel rows per character, and as you have suddenly you have 50 character rows on the screen. So what you can see here is then I can show you how you can access that memory. 20 of course is the hex value for space and not the decimals value for space. So as you can see, my mind is still working in hex sometimes. So, and that's the continuous memory, and you actually have 4K of video memory that is working here. Of course, it's not supported on this kernel. Maybe at some point in time it may be supported as well. What I've also done is I have been working on a separate version of the CPLD, so that if you program that CPLD with a different logic file, you can actually have a much more accurate CRTC emulation, but it really only works in 4032 mode because it takes so much space on the internal registers in the CPLD that anything else had to actually go away. But then you can actually do something very nice, which I'm going to show you now. Okay, so what you see here now is that I have attached a Commodore 64 keyboard to the MicroPad, and by using the special version of Steve Gray's Commodore PET Editor Rom that supports, or at least is beginning to support, Commodore 64 keyboards, you can actually use a Commodore 64 keyboard on the MicroPad, and the ROM is actually adapted such that you can just select your preferred mode on the Commodore 64 keyboard, and because it knows that this 4 key is something different than the 4 key on the number pad of the Commodore PET, it actually knows which keyboard is attached and automatically selects the correct keyboard implementation, as you can see.
So what you see here is the design for the MicroPad release 2.0a, basically not yet completely finished, but almost. So you see a couple differences. So we have a card edge connector for the IEEE 488. You have a card edge connector for a tape port, so you can actually use, or I hope it works at least, something like PET2SD or anything like that attaches to the IEEE port and gets the power from the tape port. User port is not as a card edge connector, but as a pin header connector here. There are two adapters for two connectors for keyboard. One is for the Commodore 64 keyboard and one is for the PET. The reason for the difference is because the PET has 10 rows of keys and the Commodore 64 only has 8 rows of keys and is using 2 pins for the restore key. Because I have a PETSCII keyboard, I'm also using an extra connector to provide power to the PETSCII keyboard's shift lock emulator, And also I'm going to be using the 2 separate keys next to the space key separately. There's another pin header for the second tape port. This is the programming port for the CPLD. And then basically on the right hand side you see the complete Commodore PET I/O. We have the 3 I/O chips, the 2 PIAs, and we have the VIA. And then here this is the IEEE 488 section, where you have the bus drivers, which is a 74LS641 type of chip, which has enough power to pull down to draw enough current from the bus to support the IEEE 488 standard, required standard. And then we have the pull up, pull down resistors here on here. So this is all kind of compressed schematics from the original PET, but using different driver chips, because the original Motorola 3446 are basically unobtainable anymore. Here on the left hand side we have the the more modern part. We have the 65816 CPU. Again, all those Commodore chips are in the PLCC sockets. We have the CPLD, which is the same as in revision 1. We have the Video Rom, which is the lower one of those RAM chips here, but we also have the option to use what I call fast RAM, which is more or less directly connected to the CPU and is not it does not slow down the CPU when video access is required to display the video data. There is the Vga adapter now included on the board itself. We have the driver chip for the Vga signals. There is some the resistors and diodes that are used for to create the proper Vga output levels. And we have the Vga connector here, and we have another pin header here to be able to connect an adapter that I think I'll be designing as well to convert the Vga directly to HDMI. So just instead of soldering in a D-sub Vga connector, you can just attach an adapter here to have a HDMI output, including sound. Also, you can see here the IEEE 488 also has a pin header, and there are some drills, holes here. So the plan is to have a small adapter board that goes on top of that pin header to have the actual IEEE 488 connector provided as an option. There is a reset key. Finally, I didn't forget it. There is a power supply connector. There is the audio jack. And then we have on the left-hand side, there is again, sorry, I'm jumping around a little bit because I didn't script it, so forgive me for that. There is the SPI Flash. It's the same as we have on the release 1. So as you can see, this is really a small chip, and so it doesn't need much board space here. As I have managed to put in a proper SPI interface into the CPLD, I was also able to take advantage of more modern types of interfaces. So the first one, as you may be seeing here, is there is place for some coin battery, and there actually is a small SPI type real-time clock chip in here. So you can use the SPI interface on the CPLD to use the real-time clock here. There is another pin header for another SPI interface, and this is actually the same connection as as is being used by an SD card adapter. I found. So you can add SD card adapter as well and use these memory cards. It just didn't fit onto the board anymore. What we have here is this is a small USB adapter chip that I have been using on user port adapters for the Commodore PET to attach a mouse to my Commodore, and there's the USB connector here, and then on top of that there is a space for an Olimex Ethernet adapter using the ENC28 something 60 chip that I have been using on my designs previously as well. So yeah, I think this is the most complex board I've ever done so far, and as you can see, it really is packed full with signals and lines. I've managed to pack it all into the CPLD. It's basically completely packed. Almost all the microcells are used. So yeah, now the only thing is for me verify some layouts of parts, and order the parts and have the board made and build it. Yeah, so I'm really looking forward to building that machine and testing it out. So that's it for today. Thanks for watching, and see you next time.